What's up, everybody? I'm here at BattleAero with the Pink Ribbon Racing Indotech Motorsports 2020 Toyota Supra. We have big plans for this car. It's been a while. We were going to make this into a time attack car, and then a giant global pandemic happened, and we had to put everything on hold. But we're back. We're actually making progress now. This car is going to be back and on the track sooner rather than later. So follow along. We've got a lot of cool stuff coming. We're going to start here at BattleAero with, of course, the aerodynamics. Let's check it out. I'm here with Caleb.
Hi.
Caleb's helping us out with some aerodynamic parts here. So kind of the whole point of this build here is not to just buy a bunch of parts off the shelf and shove them on the car, because we're not building a street car, we're building a race car. And we want to make sure everything is as effective as possible for the purpose that this car is going to serve. So what we're doing here is developing some parts from scratch, basically. And yes.
We've got these 3D printed prototype test brackets that we're going to fit to the subframe. And it goes on like this. We have a couple of brackets all around, so we're just going to be testing those, the fitment of those today, and hopefully be able to put a splitter on it.
This just came off a 3D printer from Type 6. It takes like 24 hours to make these things, and it's made out of this carbon plastic. It's just a really good way to prototype the parts so that we can make sure everything fits the way it's supposed to and make adjustments before we make the final run of the parts. So this is going to be bolting to, this is an OEM piece here. It's part of the aluminum subframe. So it's fully chassis mounted. So when there's a whole bunch of air hitting the splitter here and creating downforce, it's pulling down not on the flimsy plastic bumper, but on this solid aluminum subframe. So it actually pulls the whole frame in the car down and therefore translates more of that air pressure into grip. The final piece will be carbon nylon, which will also be 3D printed, but it'll be much more rigid than this. It will match the rigidity of the splitter. So, and it's also very lightweight. So it's a good material for this. All right, so that's how we make the brackets and stuff. But the actual like splitter parts, we got to design them as well. And that's what's going on over here. And this is a really cool process. So this is a 3D render of the front end of the Supra, and you can see it's got a splitter on there already. So this is more or less what it's going to look like. You know, it could be green, orange, you know, put conias on the back, save 3 pounds, be good for the whole shot.
Give us better traction for the whole shot.
Nobody's getting my terrible reference. You guys got to watch more bad movies.
Man, you should be going to MIT or something.
Talk to us about what that is, Caleb.
So this is our Artec 3D scanner. It's a white light scanner. What we do is we mark up the car, we scan the car, we process the data, and then we import it into this program called SolidWorks. And then in SolidWorks, I can start using the scan as a reference and start designing these brackets and these parts. So this is the splitter we have, but if I do this, hide the splitter, you can see all the brackets we showed you before, the 3D printed parts.
So right here? Yeah, right there.
That bracket right there.
And then there's going to be another one right up here. There's
right here.
another aluminum bracket that goes across the front that holds the bumper in place.
And then we have one more on the side right there. So you see how powerful this tool is, that we can just design straight off the scanner and be as accurate as possible. Traditionally, before we used the scanner and all that, we did everything by hand. And it was a lot slower. There was a lot more room for human error. This way we can prototype a lot faster.
Now, could you take this scan of the car and export that to do different things too? Like, could you run this through an aerodynamics model?
Yeah, we could totally do that. We just have the front half of the scan for the car right now, but if we were to get the whole scan, we could totally do that.
So you could estimate how much downforce it will actually create.
We can do CFD and all that.
That's awesome.
It's just you know how far we can take this.
Yeah.
But it's really cool. You can, once you have the solid model of the scan and the parts, you can literally, like, the possibilities are kind of endless. That's the great thing about like computer generated models.
Yeah, and so rather than just like putting parts in the car and guessing and saying like, let's hope that this is the amount of downforce we want. Well, not just that. Like, let's hope that this shape is going to be effective.
Yeah.
You don't have to guess, because you can get like 90% of the way there.
Yeah.
And say like, we know that this is going to be at least close, and then you might have to do some fine tuning after that.
But yeah, and then also this way we can make sure if we have like a rear wing or something, we can make sure that aerodynamics are balanced out. Because if you have too big of a splitter or not big enough, and you have like a triple element wing or something, you want the downforce to be to work all together. You can't just have too much downforce on either end of the car.
Caleb, why are you working in the dark?
Oh, because we're gonna scan. So you guys will see this in a little bit. They're gonna start scanning the scope R, and you can kind of see the whole scanning process.
this is what our splitter will look like, right? Overall. Okay, but I've added new profiles to it. So this is going to be the diffuser. That will basically channel air out, away, and should help airflow better. It should. It should. It's all in theory until it actually works, right? And then we're also going to add the wing elements here, and kind of like an infinity wing design type of deal going on. That's where the idea is from. But yeah, all that will get added onto the splitter later.
Okay, so check this out. This is the CNC machine here that's going to cut the material into, this is going to be a splitter here. So there's different types of material that you can use for this. This is birchwood, and it's got this honeycomb looking pattern on the top of it, but it's just a pure birchwood core. This is what the core actually looks like. So it's multi-layered, kind of a ply board sort of thing. And then it's got this sort of plasticized layer on the outside. Now they can be just like that, or they can put a carbon layer on top of that if you want it to look like a carbon splitter as well. We're going to be using a different material for our car though. It's, I haven't even seen it yet. In fact, I just learned that it existed specifically when we were talking about this project. So it is still made from birchwood, but it's a birchwood honeycomb core, they call it. So it's sort of like an Alumilite, but it's made from wood. So the idea here is that we wanted to move away from Alumilite. And Alumilite's a great material. It's really strong, it's rigid, and it can take a lot of pressure from high air pressure. But the problem with it is if you hit a curb or a rock or something in the track, it's going to bend, and then that's it. You throw it away and you get a new one. We're trying to get a material that's going to be light, but also resilient, so that we don't have to keep making new ones and keep replacing it all the time. So we're hoping that this birchwood core is going to do the trick. And there's one more material we might try as well, and it's a polyurethane honeycomb core. So that's a type of plastic. So that should be even more resilient. So it's a combination of cost and weight and strength to try to find what's going to be the best material for the application. And we'll figure it out. We've got a couple options. All right, so this one here is the same as what you just saw inside. This is the coating that comes with the birch core. So that's what they normally look like. And then if you want to take it up a notch, this one right here is the same type of core, but with a carbon overlay on top. So check this out. So this is the CNC mill, and this is the birchwood core that's being cut into the first iteration of the splitter for this car. So this, of course, is the outline for the whole splitter. This is a cutout here for some of the OEM parts underneath the car. The length of the splitter here is dictated by the rules of the series. So we're allowed to go, I believe it's 5 inches, 4 of the front bumper, and all the way back to the center line of the front axle. So this is where the center line of the wheels is going to be right there. You want to use as much of that space as you possibly can, but if you go any further back, you're outside of the rules to get DQ'd. So take advantage of as much as you can. And what you can see from outside of the car is only about that much. And yeah, a lot of the work is done there, but a lot of the work is actually done underneath the car as well. So the larger this surface is, the more effective that splitter is going to be. And because this car has so much factory underbody panels on it, it's almost a totally flat bottom. That makes this more effective as it goes all the way towards the rear bumper, where we're going to have a pretty nice big diffuser there as well. So it's all going to be one cohesive package that works together. So right now the car is totally stock. The only thing that's changed under here is we've removed a piece here for these brackets. But as you can see, imagine there's a piece of plastic here that covers this up. Between the metal under tray for the engine, these plastic pieces here, these fiber pieces that go back all the way, all this is covered up. Even the exhaust is ovaled out. That's partially for clearance, but partially because it smooths out the air. All of this is flat. The only thing that's really open is right here for the muffler, right here for the exhaust. Other than that, it's pretty smooth. You see that in a lot of newer cars. It's an advantage that you don't have in a lot of older cars, and that works, it plays to the rule set really well, because you're not allowed to add a flat body, a flat underbody to the car, but if it comes with one, you're not required to take the OEM pieces off. So we get a benefit here that an older car wouldn't have. And that's going to mean that when we install the diffuser, it's going to make it way more efficient. So it's going to be a totally flat surface from 5 inches in front of that bumper all the way back here, all the way to our diffuser, which is going to start right here, also at the center line of the axle. And it can go back, I think it's 3 inches behind the rear bumper. So something like right there. And that's going to be angled up this way. This muffler is going to be out of the way. We're going to try to do a single exit exhaust in the center. So that'll free up all this space. The diffuser is going to be at an angle like this. And that's what creates this area of low pressure underneath the car and creates some downforce. So what are the odds that this just like bolts right up first try?
You know what? That depends on how good my skills are. So we'll find out.
Okay, good.
And according to the scanner and design, it bolts up first time.
What dimensions did you cut this to? Like how much?
So
How much is it going to stick out?
We're about 2 inches off from the edge, and then we radius out to about 4.5 inches here, and then just keep that throughout.
So is it going to follow this contour?
No, it's I just follow the simple arc. This profile we can change to whatever. I just did the most simple generic one so we can see how it looks and then go from there.
Gotcha.
I didn't follow like all the curves and stuff just yet, but we can easily do that because we have a scan. Works. Yes, sir. Twist it. Stop there. Oh, so cut out the chop. Sick. Alright. Nice.
That's really cool. So right here, this was a cutout we saw while I was on the CNC. So this is the factory bumper right here, which is lower than the factory lip looking splitter type thing. I don't know what it's officially called, but so that's the lowest part. So in order to get the splitter to sit flush, they made these cutouts here so that it could come out here. Take a look at this. You can see it sits up against that lip, the factory lip piece there. Very clever. And then the mounts are here.
Yeah, they're around here where the holes are. So I'm gonna just need to go under with a light and then just check. But they're looking like they line up.
So one mount there to the subframe, same on the other side, and then there's one here as well.
One along the center.
That also goes to the solid aluminum bumper core. This big gap here.
Oh yeah, so we're gonna have to create an air dam. So we'll create an air dam that bolts up to the splitter that shields off this gap right here, because obviously this is no bueno for the downforces.
So the finished product will not look like wood here.
No.
It'll probably be a little bit wider here.
Yeah, we can totally do that.
This will be covered up,
Yeah, air dam.
and probably a couple of
Yeah, we'll probably have to
rods.
rods.
What's your thoughts on struts versus cables?
They both create a lot of drag. So ideally you don't want either of those. Cable's a little bit better for impact because it'll bend, right?
Yeah. So what we're talking about is the struts are what you typically see. It's like a turnbuckle with the aluminum rod, and you can adjust the tension on it. The problem with that is if you hit something solid, like a curb or something like that, or a rock, or somebody lost a part off their car, it doesn't have any give. So it'll break the split. Yeah, it'll break everything maybe, or break your rods. If you use cables, they have is tensile strength the right term? So when you're creating downforce, it's putting pressure here, the cable's tight and it can't move. So it transfers all that force into the chassis. But if you push up, it's just a piece of wire and it'll bend up and allow everything to move out of the way and not get damaged. And then as soon as you go over whatever that bump is, boom, it's back to being a splitter.
Yeah, but ideally we want nothing, but that's a lot easier said than done.
So Caleb, what is the timeline now on, like, what's next steps?
We're gonna make these out of metal now.
Yeah.
Make these out of metal?
And then we're gonna resize the splitter so it's the correct size to the racing class. You know what I mean? So that's the next thing we're doing.
Cool. So when can we pick it up and get it all ready to go so we can test it out?
Probably give us a few weeks. Yeah, we have a lot of stuff being manufactured right now.
Cool. Well, that gives us time to get some of the other stuff we need, like wheels and tires, and the suspension's on its way, but it's got to actually come in before we can use it. So cool. Well, a couple of weeks we'll have a bunch of new stuff on the car. We'll get to try it out. All right, man. I appreciate it. Thank you very much. This is awesome. It's coming together really good. I can't wait to see the finished product.
Yeah, thanks for coming by.
No problem. We'll see you soon.
Yeah.